or your kilowatt hours. Your kilowatt hours are your kilowatts times the number of hours being used. So this is actually what you're being billed on. This up here is called apparent power. It's not real power or total power or anything else. It's called apparent power, kilovolt amps. Okay, it is based upon the current. Now the current value is going to change as this item here changes, which is your phase angle. As the phase angle increases or decreases, as it increases, you'll see a little more current on the line. So this will go up and it'll elongate and you'll get a little more current. Or it'll decrease as the current comes down on this phase angle. The phase angle itself is not measured as a true angle in the calculations I'm going to show you. If this were at 90 degrees straight up and down, that would be a 0.0 power factor, which of course is not possible. If these were directly in line with each other so they were perfectly equal, which would be a pure resistive circuit, that would be a 1.0 power factor. Okay? Now over here we have kilovolt amps reactive. This is the power necessary to energize the magnetic fields in a coil. And kVAR capacitive. This is 180 degrees out of phase. So if I add more capacitance to my circuit, this angle begins to come down. As it comes down, this value comes down and I see a difference in current. Okay? The actual kilowatts, single phase kilowatts is what you'll see in your home, is volts times amps times the power factor divided by 1,000. Three-phase power is volts times current times the power factor times what is basically the square root of 3 or 1.73 divided by 1,000. As you can see, power factor is part of that. So as I come down closer, my current may drop, but my power factor increases, meaning my kilowatts are identical no matter what I do to change this phase angle or power factor by adding capacitance to the circuit. If I add more capacitance, I come even more in phase, okay, and I end up with a little less current with more capacitance. So if I add capacitance, here's what happens. If somebody's demonstrating one of these devices, they'll take an ammeter and they'll attach the ammeter to it, to say an electric motor, and they'll show and say it's drawing 10 amps. And then they'll turn on their little device, and it'll drop down to 7 amps. Okay? You have changed the amount of current flowing in the circuit. You have not changed, however, your kilowatts or real power, what you're actually billed on. And this is where the scam comes in. They demonstrate it in current only. If you want real proof, have them show you a change in power factor or kilowatts. Okay? Now here's where the real danger comes in, because most of the time they sell you a box, and you get this box and it's installed in your home. They don't bother trying to size it for your minimum loading. That means if you're not running, if you're at the time your refrigerator's not running, or your dishwasher's not running, or whatever's running, your air conditioning, whatever's running an inductive load is turned off versus on. Okay, you have to size it by everything being off. If you have everything off and the capacitance is in place and you're running your electronics, you end up with this.